Did you experience this in your class when the teacher would come and tell you that I'm taking you all out now during this period and make a line, and all of you all would make a line inside the class, and the first one near the door is already ready to run on the ground, but just because the teacher is there, the entire line is just present in the class, because the moment the teacher would say go, all those first 2 or 3 of the students are ready to run and go. You will experience this. Can you imagine this scenario in your mind right now? If not, then think about it as this intro is played. I'm sure you must have by now imagined and got back to that scenario that I was talking about. But why am I telling you about this? This is a kind of a situation or a scenario that happens with particles of matter as well, and especially in the case of evaporation. So what is evaporation? It is nothing but the change of state of a particle from liquid to gaseous state below the boiling point is called as evaporation. Now let us think of it with the example that I had given you. On the surface, right, of a liquid, say maybe in the sea, or maybe in a lake, or maybe even a cup that is having some liquid in it, you keep it out, after a while there's always an evaporation taking place, considering a certain factors involved. Now we'll talk about those factors in the next video, not today, but let us just understand what happens when an evaporation takes place. So on the surface, right, of the liquid, all those particles whichever are there will always possess kinetic energy. If you don't know what is kinetic energy, then I would suggest that you just go ahead and watch those videos with regards to kinetic energy, with regards to diffusion and so on. But all particles which are moving, they possess kinetic energy. So basically in a container, they don't have container here. Okay, so just look at it, imagine. Okay, so imagine this entire container is filled with some liquid. Okay, in this case it is the color. Okay, and every particle which is there possesses kinetic energy. Okay, and those particles which are on the surface, which are directly meeting the gaseous environment, that level on the surface, those particles possess little extra kinetic energy. Like those students who are near the door and ready to run, like that. So the moment there is a little bit of heat supplied, okay, because of the environment, or even if you don't supply heat, they will take the heat that is there in the external environment, and since they were all ready to move away, they take that much of heat and change its state from the liquid to gaseous state, and thereby evaporating or moving from that liquid state to gaseous state. That will be called as evaporation. It is happening below the boiling point. Now why below the boiling point? Is because boiling point or the boiling effect phenomenon happens when the entire content of the liquid is supplied with heat. It's a bulk phenomenon. Evaporation is not that way. Evaporation happens only at the surface. So the moment the particles which are on the surface, they already have more energy, so little bit extra energy that is given to them, they'll move away. Just like those students, when someone behind them will tell them, "Arey, wasre," that wasre is just the change of state that happens. I hope this part with regards to evaporation is clear, and if you want to read about it, you can check out your textbook, it's there, read about it, and probably you can make your own notes with regards to evaporation. And in the next section of this video, we will understand what happens or why evaporation causes cooling. Here is, I have a small container with, acetone, and I have just applied a bit on my hand. Now, you must have also tried this, maybe acetone or nail polish remover. The moment you put acetone on your hand, you'll realize that you have a very cool, soothing experience, or your hand feels cool, and finally that acetone has just disappeared. So it's already getting disappeared from here. I'll just apply a little bit. I don't know whether you'll be able to see, but I'm having that very nice cool sensation, that feeling right now. Okay, but the acetone is gone. So what has happened over here? Why wouldn't the same thing happen if I would put a little bit of water on my hand? Okay, now the thing is, this acetone, the particles, okay, they already possess kinetic energy. So the moment they touch the surface of my hand, they are gaining that heat energy from my hand, okay, and they are moving into the gaseous environment. That means the change of state has happened. They are moving from a liquid state to gaseous state when they have taken that heat from my hand, right? Now, since that heat is already taken away, there's no heat left, right? So because that heat is gone already, that's the reason your hand feels cool at that point, but not everywhere else. Because if I put acetone over here, I will feel cold at this point, not over here, because this part already has the amount of heat whatever was there, body temperature. But this phase currently will automatically change because that heat is taken by all the particles of acetone and changed its state. That is why evaporation causes cooling. Now, if these two things you have understood about what is evaporation and evaporation causes cooling from this video, then I would suggest you to hit that like button. You can share the video with your friends and subscribe to the channel, and please, you can take some time and write in the comment section whatever you feel about the video, anything you want me to improve upon my explanation, or some more examples you require, anything, please feel free to comment, because unless and until you tell what are you expecting from me, then I would not know, right? So feel free, just have that much of faith that no one's going to judge you for sure, because no one knows you whenever you comment there. So don't worry, and even if I know you, it's purely okay. I'm not going to say anything or judge you based on whatever you write. So feel free to write whatever you feel. Secondly, one question for you to think about, ponder upon is, why do we wear cotton clothes in summer season? Also, second one would be, whenever you have these, I don't know whether you have it, but these olden earthen pots, whenever you would drink water from those pots, there would be always that coolness which you don't feel that way in the normal steel containers when you keep water in. So how is it different? What happens when you keep water in the earthen pot? So you can probably, if you have your grandparents, ask them also what are their opinions with regards to this. Why would all our grandparents keep water stored in that earthen container? I don't know what exactly you call it in your area, but in my place they would I think call it as, in Konkani, gurgulet. Okay, if you have a different word, what you call it, it's like that a rooster kind of a container which will have a face of a rooster, and then that entire earthen pot. So they store water in that. That's what I'm talking about. So I hope this video has given you some insight with regards to evaporation and how evaporation causes cooling. And if you did like the video, please go ahead and hit the like button. Till then, bye bye. Little bit of acetone that's left.